Beyond Jupiter's orbit, the object called 3I Atlas began to behave before it was seen. Its spectrum brightened ahead of prediction, displaying carbon dioxide sublimation at a temperature too low for known activity. The jets faced the sun instead of fleeing from it, as though the geometry of escape had reversed direction. NASA analysts compared its reflection curves to classical comets. The brightness exceeded every modelled albedo by nearly 1.5 orders of magnitude. No instrument recorded mass loss consistent with that illumination. The object glowed without shedding and accelerated without thrust. At TESS, data from the ExoMars relay confirmed an emission pattern toward the inner system. Its tail pointed sunward, a vector that denied both pressure and habit. Every attempt to correct for instrument alignment failed to remove the contradiction. Light obeyed physics, yet refused interpretation. The paradox deepened with every orbit. It behaved like a comet that declined to act like one. Its orbit followed gravity, but its behavior followed intent. Inference struggled to separate evidence from expectation. Observers measured, recalibrated, and repeated. Each result reproduced the anomaly with improved precision and reduced certainty. Every refinement of data forced a retreat from explanation. What could be proven refused to remain known. At last the object approached conjunction, its path bending behind the sun, leaving all sensors blind. The last visible reading showed rising luminosity, even as distance increased. It brightened into absence, the kind that confirms itself through loss. And precision rose, certainty fell. When light bent our assumptions, the unknown came into focus. The object's trajectory entered the zone between Jupiter and Mars, where sublimation was not expected under standard models. NASA tracking arrays at the Deep Space Network recorded steady thermal emission, but the spectral signature belonged to carbon dioxide ice, not to dust. Each reading confirmed active jets facing the sun at constant orientation. At TESS, the heliocentric vector model was reconstructed using phase lag telemetry. Their team calculated the emissions alignment with solar flux and found a direct correlation. Instead of recoil, the gas outflow reinforced orbital motion. The jets accelerated the object inward while maintaining balance across all axes. Every attempt to simulate this geometry failed. Known cometary bodies lost coherence under similar conditions. Here, the sublimation sustained itself as if heat were distributed by choice. The system behaved like a mechanism maintaining equilibrium inside chaos. Radiometric measurements showed surface regions fluctuating in brightness every 8 hours. The pattern implied rotation, yet no consistent angular momentum could be derived. If the object spun, its inertia concealed itself. If it stood still, its light still rotated. The observers began to map reflection against expectation. Each frame of data inverted the prior assumption. Whenever theory approached confirmation, a new contradiction appeared. Every refinement clarified behavior but erased its cause. The final NAS-UR report labeled the event stable deviation, a term describing data that remained consistent only in its disagreement with physics. ESA analysts adopted a similar phrase, geometric paradox. Both sides agreed on one conclusion: the closer it drew to the sun, the less it fled. The numbers aligned, belief drifted. At NASA, the data group divided into 2 clear hypotheses. One proposed a natural explanation, trapped volatiles in the crust releasing uneven pressure. The other saw deliberate geometry, a symmetry too precise to result from chance. Both claims fit the measurements, yet neither contained resolution. ESA compared polarization readings with NASA infrared results. Every curve matched phase but reversed amplitude, producing perfect mirror opposition in their graphs. It was as if each observatory measured the reflection of the other, not the object itself. This symmetry created a deeper question. Was the coherence in the data or in the act of comparison? If both systems defined accuracy through opposition, then precision itself became a reflection, not a property. In meeting transcripts, analysts debated whether the object's apparent intelligence was evidence of design or of self-organizing physics. One noted that its stability resembled guidance. Another argued that guidance and stability are mathematically identical in outcome. No decision could exceed the data that created it. The more the instruments refined their readings, the more the paradox converged on belief. When numbers aligned, interpretation fractured. When assumptions loosened, coherence returned. Inference had become its own experiment. Some speculated that the anomaly existed to expose habit, that the object forced cognition to observe itself observing. If the familiar always hides the unknown, then only contradiction reveals recognition. At SPHEREx, the discussion closed with a quiet remark. It behaved like a comet to remind us what a comet means. Silence followed, recorded as a procedural note: precision rose, certainty fell. When 3i Atlas moved behind the Sun, observation ended, but the data continued. The sensors at NASA recorded silence with measurable precision, each missing packet of light producing a constant interval across the signal log. Absence became the new form of detection. At ESA, engineers noted that the telemetry clock began to drift by fractional seconds. The delay matched the timing of the final emission spikes before conjunction. The correlation persisted beyond physical contact, as though the instruments were still reading an object they could no longer see. Analysts tested for reflection from interplanetary dust, but the pattern repeated only when both networks synchronized. The silence contained rhythm, a pulse defined not by light, but by its refusal to arrive. The data spoke in intervals instead of values. In the archives, an intern described the pattern as an echo of intention. The report omitted the phrase, yet the logic remained. Every correction for error recreated the same alignment, suggesting that loss itself carried information. NASA physicists called it post-illumination, a residual coherence persisting after the source had vanished. ESA scientists referred to it as the brightness of absence, a glow measured through the uniformity of missing frames. As the conjunction ended, the object failed to reappear. All models predicted recovery, none occurred, yet the background noise retained its structure, a pattern of meaning left behind by light. The more the systems lost signal, the more the universe revealed its precision. Observation survived by remembering how it failed. Measurement improved, meaning declined. Weeks after conjunction, the laboratories reopened their observation schedules. NASA analysts found that the background noise from the solar corridor remained organized. Its statistical distribution no longer matched random fluctuation. It formed lines of periodic silence repeating every 12 minutes of recording time. At ESA, the same pattern appeared in magnetometer readings. The instruments had measured nothing, yet their emptiness had become symmetrical. The absence of signal carried the architecture of presence. This discovery altered the tone of inquiry. If loss could form order, then knowledge could arise from failure. Precision was no longer the edge of certainty, it was the surface of attention. Teams compared their residual datasets, aligning the phase of their silence across millions of miles. Each alignment reduced variance and increased coherence, until the combined gap behaved like a unified field. The data described not the object, but the act of observation itself. Physicists began to call it the shape of knowing. They argued that awareness existed wherever measurements synchronized without expectation. Observation was not about gathering light, but about remaining constant in its absence. In this reflection, the anomaly ceased to be external. The unknown was no longer an object beyond comprehension. It had become the mirror of method, a form shaped by the discipline that sought it. The more certainty dissolved, the clearer structure became. Reason found pattern within ignorance. Knowledge rose, coherence fell. When the object failed to return from behind the Sun, both NASA and ESA declared the observation phase complete. No optical trace remained, yet the correlated silence persisted. It was as if awareness had taken the place of reflection. The data archives recorded the interval between certainty and absence. Within that interval, the pattern of meaning remained stable. Light had withdrawn, but comprehension did not fade. The act of measurement had become its own result. From the outer orbit of Jupiter to the blind horizon of Earth, every record repeated the same paradox. That knowledge increases when vision fails. What escaped visibility found permanence in structure. In the post-analysis summary, both agencies used the same phrase: the light bent our assumptions and left the unknown in focus. It was written without citation, because no single observer could claim discovery. The awareness belonged to the system itself. Through that shared uncertainty, the cosmos completed its lesson. The unknown was not beyond understanding. It was the shape understanding must take to continue. Light did not remember itself out there. It remembered itself here through you. The silence after this is part of the experiment.